Okay, so for this week's topic, we have Mark Studley here to talk about the sort of current status of the JitBuilder technology that exists in OMR and what we plan on doing with it over the next few months. And we certainly want to hear everyone's anyone's opinion that they have on it and areas that they think we should go with it and how they can contribute and that sort of thing. So so I'll stop rambling and I'll turn it over to Mark and take it away.
All right, thanks, Darrell. So I'm Mark Studley. I'm a project lead for Eclipse OMR and also for Open J9, and I have the honor to be the creator of the JitBuilder library, which I guess uniquely positions me to be a person talking about what the current status of the project is and where we're trying to take it. People often ask me what all is happening with JitBuilder, and often the answer only exists in my head. So that's a form of excellence that's actually a kind of failure. So I accepted this invitation to talk here as a way to pressure myself to write more of these things down and to create issues at the repository where people can give us feedback and can participate in the creation of this plan and the evolution of this plan. So this presentation is really a starting point of basically dumping the thoughts and ideas from my brain, and that's hopefully meant to spark some discussions on what would be the most effective things for us to continue doing going forward. In terms of an agenda, there's kind of three basic areas. I'm just going to give a quick introduction to the JitBuilder library for anybody who doesn't know what it is but happen to be listening to this presentation, and give a little bit of status on some of the current projects that are using JitBuilder. I'll then switch over into the focus areas for three different types of work that's going on at the project right now, and that I'm hoping will complete within the sort of time frame of the 2018 calendar year. And I'll wrap up at the end with hopefully some easy ways for people to get involved if they're interested, after I've hopefully motivated you to be excited about this project. So the JitBuilder library, it's basically a native acceleration library. It's a really simple API wrapping around the OMR compiler component. And the emphasis in designing that API was really around ease of use and trying to avoid some of the complexities and subtleties of the underlying technology used to compile code. It's also designed for use by programs to generate native code. So it's not written along the lines of trying to make it super easy for humans to understand and to generate. It's not meant as an alternative to a programming language because it's a lot more verbose than that. But it's meant to be easy to write a program to use the API to generate native code. And that means it's really created for writing just-in-time compilers, but it can be used really to accelerate just about anything, any kind of operations that you want to generate native code for at runtime. The library itself is already quite useful. There's quite a lot of things that it can do, but there's actually quite a lot more that it could do. It's currently a library that's implemented in C++, so it best supports people who want to write C++ code. And it supports a wide variety of primitive data types, arithmetic, control flow operations, etc. So this page is not something I'm going to go through in detail. It's really just a little compendium of all of the different things that you can currently do with JitBuilder. And so it's a fairly rich set of operations that you can do and rich types that you can work with. But as I say, there's always more that we can do and things that are missing. So lots of things have been built using JitBuilder, and so I wanted to just kind of start with a one-slide summary of some of those projects because it's actually quite an interesting variety of things. So the first on the list is the Lua Vermella JIT, which was written by an undergraduate student actually, which implements all but one of the opcodes in the Lua 5.3 virtual machine. And with about 3,000 lines of C++ code, the student Leonardo created the Lua Vermella JIT, and we've been making improvements in it to improve performance and keep moving that one forward. The ROSI pattern language is another example, a just-in-time compiler that we wrote using the JitBuilder library with about 1,200 lines of C++ code. And I'm not going to go through all these in detail, but there's a JIT for Swift, which is about 1/3 of a JIT for Swift. There's a Smalltalk runtime that's had a JIT created for it. At the OMR project, there's a runtime called Base9 that we're using to develop a tutorial around how to use the OMR project and the OMR components. A very cool one that I just watched the final project report for, actually just before this meeting, is a WebAssembly JIT that was created using at the University of Calgary using JitBuilder. And in the course of a one-year project, most of which was in the second term, they've implemented basically 80% of the WebAssembly opcode set using about 2,000 lines of code, and that's speeding up WebAssembly programs by factors. Mandelbrot, for example, was 14x faster, and there's still a lot we can do with that to make it even better. But as an undergraduate project, that's a pretty cool accomplishment to start from zero. We have T4, which is a JavaScript implementation, and also this Kaleidoscope JIT, which was meant as a sort of comparison point against the LLVM tutorial. I included links here for all of these projects in case you want to learn more, but one of the things I just wanted to highlight was the amount of code that people had to write to use JitBuilder. So maybe the performance that you can see in these JIT compilers may not match the 100x numbers that you hear with other projects, but it also comes with a much lower investment level. And we're always improving OMR and JitBuilder to try to improve the performance, and we're hopeful that we can get there without requiring a massive amount of investment in terms of a JitBuilder client. So there's nothing here that's more than 3,000 lines of code in any of these projects right now. All right, so that's just a quick summary of JitBuilder and where we are today. But the real question here is what's coming next, what's coming down the pipe. So there are really three focus areas in my mind for JitBuilder in the 2018 year. The first one is really to broaden the scope of access to the JitBuilder library so that you can use it as a native acceleration library for multiple languages, not just C++, where, as you saw, most of the current projects are based. A second area of focus is around integrating the JitBuilder API with some work that's been happening at the Eclipse Open J9 project that will be open sourced there in the next couple of months around JIT as a service, and I'll talk more a little about what that means and how JitBuilder fits in. And finally, there are a number of functional gaps that have been identified both in the OMR compiler component and other components, as well as in the JitBuilder API and implementation itself that could be made better in order to make JitBuilder-based clients work more effectively or more easily. And so there are a number of these areas that are also in focus for 2018. There's also a number that aren't in focus, and I'll outline some of those and where you can find the rest of them. Okay, so I'll just go through these three things in order. I'm going to spend the bulk of my time on the first one, which is the multi-language native acceleration library. So as I mentioned, JitBuilder is currently most easily used by C++ projects because it's essentially a wrapper around the Eclipse OMR compiler components, which are C++ classes. It is possible to hide a compiler implementation using JitBuilder behind a C interface, but the bulk of the code still needs to be C++ because they need to access those C++ classes that provide most of the services. So basically that means to use JitBuilder, you're kind of locked into C++ right now. But, newsflash, not everyone likes writing C++ code. I know it's amazing to think that, but there are a plethora of other languages that people like to write code in that might imagine writing native accelerators and JIT compilers for. And so it would be nice if JitBuilder was a little bit more accessible to people who want to use other languages and not force people to move to C++. So the first primary goal for JitBuilder in 2018 is to sustainably, and I'll talk a little bit more about what I mean by sustainable in this context, enable different language bindings for the JitBuilder API. And there's a series of things that I've been working on over the last couple of months piece by piece, trying to put together this story. The first piece is trying to separate the client JitBuilder API from the public implementation that's currently in the OMR classes. Now, because the JitBuilder classes are OMR classes, and those classes need to talk to one another as well as expose a public API out to JitBuilder clients, the APIs kind of all mix together. And so the first step is to really isolate what the client JitBuilder API is from the implementation API that's needed inside the OMR compiler classes. And then the second piece, which is connected to the sustainability statement, is to introduce a maintainable data format used to describe the JitBuilder API. And the reason for that is so that we can then use that data format to write generators to create essentially a language shim that allows you to call into the JitBuilder API from another language using that shim. And if you can generate that shim from the data description, it automates a lot of the work involved in evolving the JitBuilder API. So the sustainability point is around if you have n language bindings, then it starts becoming an order n amount of work in order to add new API to JitBuilder, and eventually that work will just basically stall due to the cost of doing it. So the idea is to introduce this data format from which you can then create other bindings automatically, so that the work to augment or to work with the JitBuilder API is basically kept to be a sort of order one kind of operation, even if you have n different language bindings that you're trying to support for the most part. So the ultimate goal here is really a world where C++ programmers can easily write a JIT for any language in C++, C programmers in C, Java programmers in Java, Ruby programmers in Ruby, Python programmers in Python, and so on, all the while leveraging a similar style of JitBuilder API so that we can all leverage our experience using the API and evolving the API forward, and all backed by the Eclipse OMR project, where the technology exists to actually compile the language down to native code, so that improvements that we make in JitBuilder and in OMR can actually reach everyone. So this goes back to part of the mission statement for the Eclipse OMR project itself, which is to be able to leverage investments in runtime technologies across a number of different language ecosystems. And I think this would be a really great way to be able to get people using JitBuilder and Eclipse OMR, and everybody basically helping to lift everybody else's boats at the same time. So just to put a little bit of sort of a visual spin on that, I put some slides together, and I apologize for the roughness of the drawing. My cursor management in PowerPoint isn't so good, but bear with me. So at the bottom of this diagram, we have the Eclipse OMR Compiler component. It's one of the technology components in the Eclipse OMR project. On top of that is the current set of JitBuilder implementation classes, plus this API description that I talked about, which essentially has a bunch of data that describes what API is needed in order to access the JitBuilder implementation. And then on the left side over here, we have an auto-generated C++ for now, JitBuilder API. So this is a client API that can be accessed and linked into a C++ library, which can then be used by any kind of C++ program to generate native code. And so this diagram basically shows the C++ JitBuilder library akin to what exists today, but slightly these two parts right now are the same classes in the Eclipse OMR compiler. The idea of breaking out the client API essentially creates this separate piece from here, but it's being automatically generated from this API description. And the advantage of doing that is that you could also do it for another language. So in this slide, I showed a C library, so a C-based JitBuilder API. Now, this won't be exactly the same API because you can't do everything with C that you can do with C++. For example, you don't have classes that work quite as naturally in C as you do in C++. You don't have namespaces, etc. But you could use a generator program written from this API can generate essentially the same services via a C API as you're currently getting from a C++ API. And then that API can be built into a C library, which can then be linked into any C program. And now you can write a C program that can generate native code using a JitBuilder-like API. And you can keep going. You can build more languages in here. So another language that we've heard some demand for is the Java programming language. You've probably heard of it. And so here we can use another generator to write a Java JitBuilder API from this API description, and then link that all together in a Java library, which can be consumed by a Java program to generate native code. And here you have a couple of options because the JVM itself has a JIT compiler. So maybe you manage an independent native code cache, which I showed a prototype for that at JVMLS a couple of years ago. Or if you have the ability to integrate this library into the JVM itself, you might even be able to consider generating native code into the actual JIT compiler's code cache within the JVM. So there's some interesting options specifically in the Java ecosystem. Now, the next one, you could do, say, a Ruby one. You could generate a Ruby JitBuilder API and create a Ruby gem for that, and then Ruby programmers can write any kind of native accelerator using pure Ruby, which is kind of an interesting option, especially since Ruby itself doesn't have a JIT compiler right now. Or you could do that for Python the same way. Or you could do it for any language. So even as you're generating your own new language, you could create your own generator for that language, expose the JitBuilder API to your new language, and then create a JIT compiler even as you're bootstrapping your own language into your own VM. And really, the idea is that hopefully you can do this for just about any programming language that you want to expose the JitBuilder API in, and sort of build up this ecosystem of languages that have access to native code generation using a similar kind of interface so that we can share the effort and investment going forward in the JitBuilder codebase. Okay, so that's the grand vision. Sadly, there's going to be some breakage from people who are using JitBuilder right now, which I know is sad, but I think it's necessary in order for us to move forward. The first point is, JitBuilder classes are in fact OMR compiler classes, so they have names like tr::idle builder, tr::method method builder, etc. There's an issue 2397 at the OMR project where we're discussing right now these two issues here, and what is the right name to be using for in the client API world. So if anybody, I'll pause here and see if anybody has an immediate preference that they would like to offer here. But if not, please feel free to visit this issue here, 2397, and register your interest. So I'll pause for just a second. If anyone wants to speak up. All right. Not surprising, I guess. So the second form of breakage, which isn't actually a mandatory thing to do right now, but it's kind of an opportunity, I guess, to clean up the current JitBuilder API. So right now, because the implementation and the client code is all mixed together in one class, and there's kind of these two different types of, or two different notions of public. The way that I differentiated that when I created JitBuilder in the first place was to capitalize all of the services that were meant to be public for clients. And the other ones are written with lowercase, starting with lowercase, and so those are the public API to be used by other implementation classes. Is there a question? Okay, I guess that was an accident. Okay, so if I'm now, sorry, is there a question?
We're just hearing some noise on the phone line. So if you have dialed in and if you don't have a question, would you mind putting yourself on mute, please? Thanks.
So if we're separating out the client API and the implementation API, there's no longer any real reason to distinguish between these two, because the client API will only have the public client services, only the capitalized services in it. And so as a C++ programmer, I guess I've always been vaguely offended by the notion of having a capital A at the beginning of my function names that I had to call. And so one thing that I've proposed is that we could maybe change these back to lowercase, and I think that reads a lot better to me to see those the names like that. So there's also discussion going on this particular point inside 2397. If you have opinions here on where that should go, please feel free to join us there. Another interesting opportunity that we get now to, once the client API has been separated out, we can now version that API using semantic versioning to represent what's going on with the API and when breaking changes are being introduced into it. So there's an issue 1819 where you talk about that. I think that's an important piece that we need to introduce at this point. And then finally, I guess the last point that I wanted to bring up here is there's a notion of a set of languages that we might be interested in. They're basically around the ones that I listed in the previous slides. So if there's a language that you really care about to use like this, please feel free to add them to 2401. Sorry, there's some background noise on the call still. Would everyone who's not trying to ask a question please go on mute? And if someone is trying to ask a question, please go ahead. Okay, thank you. Right, so if there's a particular language that you're interested to see bindings for, please feel free to chime in 2401 there. So I just wanted to give a brief sort of notion of what the API description currently looks like. I have some change sets sitting in my laptop that I will be pushing out shortly, just to give people a flavor for what this looks like. I tried very hard not to make this look like ugly C++, but it is still C++, so I did my best. One other option here is to move to a true data format to represent these things, but for now I've just represented them as they're actually stored in C++ arrays that are put together using various helper macros like this class, fields, and so on. So the idea is that you can, in this particular example, this is what the ILBuilder class looks like. So you can specify some documentation for the class, what its name is, and flags if it has a superclass, etc. If it has a set of fields, you can list those fields here. So in JitBuilder, to make it easy for people to reference the primitive types, they're all cached inside every ILBuilder object from the type dictionary. So that's what these fields represent, are the primitive types that you can use anytime within a JitBuilder object. So that's fields. You can also define functions. So there's another macro called functions that allows you to specify all of the functions, and in each function you can, it has a name, it has some attributes, you can define what its return type is, how many parameters it has, and then a fairly succinct way of describing parameters, their names and their types, etc. As part of the API. And so you can build up the full description of the various calls that you can make against the various JitBuilder classes using this this kind of a format. Just as an example of what one of these language bindings look like. So this is kind of a part of the C binding that I've got so far. So it's creating a header file, opening it up. The prologue it issues a copyright header and so forth. You can ask for an include file. Because it's a data format that has all the classes, you can ask the API to iterate through the classes using a fairly familiar looking mechanism to iterate through. And then this block of code, for example, is just issuing a type def statement for each of the classes in the API. And then if the class has a superclass, you can include its named header file. This is a C binding, so it's a .h, etc. So the idea is to build up a set of services inside these binding files so that it's relatively easy to just spit stuff out into a header file, and then the idea is for even the generated code to be fairly easy to read, but also fairly easy to walk over the JitBuilder API definitions and do whatever you need to do with them. All right, so that's not a full explanation, and I haven't actually pushed the commit to my repo yet, so nobody can look at it, but I will do that shortly, and I will update the various issues that are relevant when that happens. I kind of gave a foreshadowing of this particular issue here. You know, the sustainability thing I think is very important. Otherwise, it will become untenable to manage many different language bindings. I want it to stay easy to add new services in JitBuilder. I want JitBuilder to stay easy to work with. And I think the API description is kind of the way to make that work, so that you only have to add the code in I guess, two places. You have to add an implementation in the actual implementation layer, and then you have to add that the description of the API that you've added and update the semantic versioning appropriately, and then just rerun the generators, and you get all the existing language bindings regenerated with your new API added into the picture. Now, that won't always work, but the goal is so that, you know, most of the time if you're just adding, you know, another version of add, for example, that works the same way all the other ones do, that the existing language bindings will just handle that, and it's really just a matter of adding a little bit of data to the API description, and then a new API will get spit out. You know, if you're doing substantially weirder things, then, you know, we may have to update the bindings, the generators, in order to handle that strangeness. But, you know, obviously we'll try to avoid doing that because it's going to be costly unless there's a really strong justification for doing it. Still, we have that pesky testing challenge, but hopefully the enablement is going to be able to stay mostly an order one type activity. There's a question in the room we have.
So this API description.
Yep.
Let's say, let's go through a scenario here, right? So let's say you find a bug in an API description that you already had.
Yep.
But you find it later, like there's already been several versions of the API been released.
Right.
And now you find a bug. Is someone supposed to get the fix to that bug by moving up to a later version of the API description? In other words, they will pick up other changes to the API as well, which they may or may not want to pick up? Or are you thinking of somehow patching in the fix to the earlier version of the API, if that makes sense?
Yeah. So when you say bug, are you talking about a bug in the implementation?
Yes.
Or bug? Okay.
Bug in the implementation.
Yeah, I hadn't thought that far ahead, I guess. So naive answer is you update to the latest version of the API, and that contains the fixes in the implementation. I guess it would be possible to do it the other way around, but that's not something that we've traditionally. That's not sort of part of the way we develop OMR right now. So I think that's more of a release question, which is an important one to answer. But,
yeah, I was afraid it was
beyond the JitBuilder only kind of.
Okay. Okay. Yeah. Just wanted to get a sense for where.
Yeah. Yeah. Basically, hadn't thought of it. A non-answer. Sorry. Right. So there are, I guess, there are some alternatives that I could have pursued here. So I could have used something like Swig, for example, to automatically generate alternative language bindings from the existing implementation classes. So that would avoid having to write new generators. However, the kind of code that you get out of Swig when it generates an API for another language tends to be really, really hard to understand. And one of the things that I didn't want to make it hard, because it's already hard enough to write a JIT compiler or a native code accelerator, I didn't want to make it any harder for people to work with the API and understand what's actually going on under the covers. You know, with a few hundred lines of C++ code per generator, most of which is boilerplate because it's C++, it's actually not that hard to write fairly transparent APIs that just do the shim work to translate the objects as they're passing through the API, and it's quite easy to understand what's going on. It looks nice, and it looks nice enough in a debugger that you can kind of understand what's going on. And that was valuable enough to me to consider or to go down this path of having my own generators, given that it's not a tremendously difficult thing to do. We might revisit that in future, I guess, but that's where it stands right now. Okay, so that's the sort of first area of focus. The second area of focus is to integrate with this JIT as a service work that I referenced earlier. So I just thought I'd start off by just describing what I mean by JIT as a service. The basic idea is just moving the JIT compiler out of the runtime process into a service that lives in another process, either on the same machine or on another machine. So there are a number of advantages to doing that. And most of the, I listed them here. So the compiler implementation, basically you can move that out of the runtime process, which means you don't have that code lying around, the footprint of that code being managed there. If you have multiple runtime processes on the same box, that means you can sometimes move more efficiently, place that code. The work to do compilation can move to a different process, maybe even on a different machine. You can move the footprint, the memory footprint that's required to do compilation inside a runtime to a different process. Maybe even move it on another machine. And those last two are actually can be quite significant effects, right? It's quite a lot of work to do compilation, and that can be disruptive to the to progress in the runtime where the compiler is running. So if you can move that work somewhere else, the runtime itself can more effectively make progress even while that compilation work is happening somewhere else. And the footprint can be quite substantial. So some JIT compilers can use up to hundreds of megabytes at the time of doing a compile, because if you're doing a high optimization compile, that takes a lot of memory. So moving that somewhere else can also make the runtime process run a lot more smoothly. On top of that, it also offers some interesting opportunities to share JIT compilation effort across multiple runtime instances, or to identify optimization opportunities using data from multiple runtimes, which is not something that existing JIT compiler technologies really have access to, because they live inside one process and they die when that process dies. There are also some interesting service, test, and maintenance opportunities that arise when you have JIT operating as a separate process, but I'm not going to focus on those here. Of course, it's not all goodness. There are of course challenges here. So anytime you move the compiler far away, you're going to have higher latencies, which means added communication paths, and that could mean slower ramp up, because you won't be able to generate compiled code as quickly anymore. Also, the OMR Compiler intermediate language currently has no persistent form, and that means that IL generation can be a very chatty kind of operation, as the IL generator asks lots of questions about runtime data structures which only exist on the client, and that communication can be very expensive. But JIT as a service could be a very good match for low footprint runtimes that currently lack a JIT, because it allows you to put the JIT somewhere that doesn't impact your footprint, and yet still get some compiled code benefit. The Eclipse Open J9 project, which is an open source Java virtual machine at the Eclipse Foundation, is currently working on JIT as a service right now. So there's community members at IBM Canada that have a prototype implementation, currently working through some kinks in that prototype, and preparing to open source it in the next couple of months, hopefully. And that will be open sourced at both Eclipse Open J9 and at Eclipse OMR. Pieces of it will go to OMR. The goal here is to steer the fundamental technology parts here towards the Eclipse OMR project. For example, establishing the compiler service, communication paths, messaging mechanisms, etc. Relying on other open source projects where possible. So I listed a couple of examples there that we're currently using. But the basic idea here is to enable more development in the open around this JIT as a service technology. and so that we can push it forward, not just for Java, but also within the Eclipse OMR project. And so the open question here is, so we know this is coming, how can more runtimes take advantage of JIT as a service without having to go through all of the additional implementation cost that has already happened for Eclipse Open J9? And tongue-in-cheek, JitBuilder to the rescue. As I mentioned before, the compiler IL has no fully implemented persistent form, which makes it a little bit difficult to generate IL in the client and then spit it across to a server. It's a very detailed and complex data structures. Many of them are extensible classes, which further complicates making this work. We're trying to make progress on this nonetheless, but it's not there quite yet. The other challenge here is that the IL data structures tend to be very footprint and compile time sensitive within the compiler, so adding new things or changing them in aggressive ways can distort the performance profile of the compiler, and we prefer not to do that. However, we have this JitBuilder thing, and its API is significantly less complicated and potentially easier to persist. So I've opened an issue 1818 where I talked a little bit about providing a record and replay capability for the JitBuilder API, where the idea is to essentially log the calls that happen to the various objects that JitBuilder works with or that the client creates, and be able to replay that log of events on the server side. I have, again, some commits that are hopefully going to be, at least in my private repo shortly, to define what I've been, for lack of a better term, calling JBIL, JitBuilder IL, binary format, which I think is an enabler for using JIT as a service for all JitBuilder-based clients. That's the goal. With the secondary benefit that it might also allow the OMR project, because you can record how the JBIL is being generated, you can actually record how JitBuilder is being used by other clients, other language clients, in order to capture compilation tests that mimic how JitBuilder is being used, even in the context of other languages, which, OMR is meant to be used for many different languages, but we can't afford to have a runtime for all of those languages available to test OMR directly in those language runtimes. So having this JBIL format would allow us to transport some of the effort that's been put into generating JITs for other languages into the OMR project and reflect what they're doing, so that we don't regularly break people, hopefully. So the ultimate goal here is a world where a JitBuilder client, even an existing one, can compile either in process or out of process with a statically linked compiler, a dynamically linked compiler, a remote service on the same machine, a remote service on another machine, and also be able to store this JitBuilder compiles and reload them to be compiled either in or out of process. And all that without modifying the client's use of JitBuilder. So I'm trying to make this transparent to the client implementation that's built on top of the JitBuilder API. It becomes basically an implementation, a set of different implementations of the JitBuilder API. All right, so that brings us to the third basic area of focus, which is to address functional gaps. So the main, I guess the one overriding point here is there's more work here than people I know of to work on it. So there's actually quite a number of issues that are already opened at the project that have been capturing the use cases that people are caring about. Some of them have gotten attention already, some of them have not, unfortunately. The point of this slide and the next couple are to sort of outline the things that I would very much like to get focus on this year, and say, this is an evolving list. As I say, this is a starting point that's kind of a dump from my brain. If you have different ideas or different needs, or you think other things would be much more important to you, then feel free to chime in on the issues that are linked here. So let me just go quickly through it. So there's a couple of platform-specific areas that JitBuilder doesn't currently work very well on the Power platform or on the Z platform because we're missing method trampolines. So it would be nice to fix that. And Windows currently has some issues as well. So there's a couple of issues there around enhancing the platform's availability for JitBuilder. Excuse me. I know of a couple of projects that are shaping up on Z and on other platforms, and so that's what's kind of driving the interest in that work. Because of the great enabling potential of inlining to provide performance and the relative simplicity of implementing inlining as the mechanism at the JitBuilder layer, there's an issue there, 2398, that describes how to implement inline call so that you can specify a call that you would like to be inlined. That will not use the OMR inlining, the compiler inliner. It just uses JitBuilder to do the inlining directly. Longer term, obviously, it would be better to have the OMR compiler driving inlining here, but until we get to that point, this mechanism is relatively easy to implement, and it would allow people to kind of play with what inlining heuristics are useful for them in their particular JIT examples. And then a third area here is around improving the integration with the OMR garbage collector component. So there's a number of issues here that mostly Daryl has opened. These are really more OMR related gaps that we need to fill around defining our method metadata. So the method metadata is a data structure that holds information about a compiled method, which we don't have a very well-defined notion of right now in OMR. It would be a place where you would hang stack and register maps, which are how the JIT would communicate with the GC on what registers and what stack locations contain live objects. From a JitBuilder standpoint, once we have that better integration, we'll want to surface the notion of a managed heap pointer as an IL, a primitive IL type in JitBuilder, so there's an issue for that. And then there's a couple of issues around code cache management that would really are things that we should get to this year around being able to delete compiled code bodies and also to better support the ability to recompile methods. There's a number of extremely useful things that I'm doubtful right now that we'll be able to devote too much attention to in the next year. So they're kind of listed here. They're all relatively important things for performance. They're things that Eclipse Open J9 does very well. Some of the functionality for these things exists in OMR, but hasn't been correctly surfaced or isn't available easily for reuse right now. So there's some refactoring work that needs to happen there, and none of them are available as JitBuilder API right now. So from a JitBuilder standpoint, if the OMR compiler doesn't have the API yet, then it's hard for JitBuilder to surface that. But we'll see if we have time. Obviously, we'd love to get to these things, but right now it doesn't look like we'll be getting to all of them. There's a link at the bottom of this slide here that just shows basically every issue at the Eclipse OMR project that has to do with JitBuilder has been tagged with the JitBuilder label, so you can find them relatively easily. And if anybody wants to sign up to help with any of these, we're perfectly willing to help people make progress on them. So, but there are a variety of different ways that you could actually reach out to help. So obviously we're very interested in growing our user base. So, please let us know what you think of this presentation, of the content of this presentation, of the areas of focus that we're looking at. If you're excited by what we're doing, please let us know. That would be great to get that validation. If we're missing the mark for you, no pun intended, please let us know that too, so we can try to fix that. If you have anything that you'd like to see that isn't listed here, please feel free to make suggestions, or if if you have other ideas, please feel free to propose them. If you're interested to pick up an item that I've listed that's not currently active, there is a top-level issue 2400, which I somehow managed to get, a nice round numbered issue. that basically summarizes a lot of the issues that are in this presentation, and is a place where I'd like to collect people's input. So if somebody's working on something, feel free to reach out there. I don't want to get multiple people working on the same thing, but feel free to document what you want to do there if you want to help. Other ways that you could help out are just writing down your experience trying out JitBuilder, and let us know how it goes. Right? It's, as I said, it's meant to be an easy-to-use library. So if it somehow wasn't easy for you, let me know and we can try to fix that. I'll reiterate the issue that I mentioned earlier. Is if there's a language that you want to use JitBuilder from, feel free to list that there. So. And even if you just want to refer this project to someone you think would be interested in it, that's actually helping us out quite a lot. Word of mouth is a very powerful thing, and we'll always welcome a new face or a new voice at the project, and we really look forward to continue to grow the OMR community. So these are all ways that you can help if you would like to. And finally, if there's any other feedback, there's a variety of different ways to reach me. That's my email, my Twitter handle. You can reach out at the OMR project itself at our GitHub site, raising an issue or any of the issues that I've mentioned. Again, 2400 is the top level issue for JitBuilder in 2018, so you can find that. Or you can even reach out at our OMR dev mailing list, which occasionally people use, but there are always people listening. And that's the end of my talk.
Okay, thanks, Mark. I guess we can open it for discussion now. Are there any comments or questions from Mark at all, or anything on the JitBuilder technology?
Shell shocked.
I guess there is a fair bit to digest there.
Well, feel free to reach out on any of the issues, or with questions to me or anyone.
Yep. Okay.
Thanks for listening.
All right. Okay. So that was our pretty much our only topic for this week. So hopefully the recording actually succeeded this week, so that I'll get that up on our YouTube channel tonight, and publicize that, so you can watch it again and again at your leisure. So. Okay, so if there's no other comments or questions, I think we'll adjourn the meeting now. Thanks everyone for attending.
Thanks, Gerald.
Bye.